the next session on the fourth module of real-time simulation studies in power systems. In this today's session, we are going to study the real-time fault analysis of multi-machine 9-bus system using OP-4510, the real-time simulator by OP-RT. Let me first show you the model which I have created in Simulink environment. In the previous session, I told you how to make your model in Simulink compatible with the RTLab. That is again which we have done here. I have made two subsystems here. One is the main subsystem which I have given a name SM_main, and the other is the console subsystem which I have given the name SC_scope. And also, as mentioned earlier, the Power GUI solver which I have taken is the discrete for the real-time simulation environment. Now let us first examine the model. In this case, in the transmission line between 7 to 8, between the bus number 7 to bus number 8, I have divided it into two parts and created a three-phase fault in between. This is a triple LG fault which I have created. What I have done is, from here I have used a measurement block, a three-phase measurement block, and I have taken the values of currents and voltages through this go-to, and these are given to a three-phase instantaneous active and reactive power. So all these are in the main subsystem. Now these are then connected to the console, that is SC console subsystem, in which, as I told you earlier, I have connected an OPCOM. Now let us again go back to the RTLab environment and see how to simulate this particular model in the real-time environment. So this window is opened. The first step is to create a project. Either, as I already told you, either you can go to the file and say a new project, or else you can create a new project from here. I give it a name, let's say NITTR1, because previously I had made a project with the name NITTR, so you should make sure that you don't use the same name. So I have given it a name NITTR1. It will create a project. So as you can see in the project explorer, a new project with the name NITTR1 has been created. The next step is to add the existing model. So go to the models, right click, add existing model. As I told you that either you can import the existing model or you can link it, but you should always import it so that any changes you make during the real-time simulation, they are not reflected in your original model. So I will import it. It will then ask me the location. So for this particular folder, there are two models. I'll select the one which I require. I have given it a name real-time fault.mdl. Now, as you can see from here, it is showing all the different MDL files which are there in that particular folder. So you have to make sure that you select only that particular model which you want to simulate. I know the model is real-time fault.mdl, so I just uncheck the other files and say finish. So you can check from here in the project explorer that the model real-time fault has been added to my project. The next step is to make the various processes in order to execute this particular model in the real-time simulator. So the first step is to edit the model. It will open the model in the MATLAB environment. It has already opened it. It has opened the model. Let us again go back. Set the development properties. Red Hat, by default it has been selected. Go back to overview and build the model. Building the model takes approximately 30 seconds to 1 minute depending upon your processor speed. So once I have built the model, the next step is assign targets. Clean target. Again go back to overview. Set the execution properties. As I already told you, in this case, we are not connecting any external hardware. That means any load or any CRO or scope. So that's why by default I have taken it as software synchronized simulation mode only. Again go back to overview and load the model. You can see the progress here and also what all steps are taking place here. So once the model has been loaded, I already told you that this kind of thing will appear. So this is a model which is automatically generated by RTLab during the compilation. That means the model has been successfully loaded. And the final step is execute the model. So the model has been executed. Let me just go there and run it. So these are the various results. As I said that when you have created a fault, the voltage becomes almost zero. So this is basically the place wherein you have given a fault. So the voltage becomes almost zero and the currents, they become very high, as well as the active and reactive power, they also become almost negligible during the fault time. So these are the results which I have got in the real time basis. So in our today's session, we have seen how to simulate a real-time environment, real-time fault of a multi-machine 9-bus system. Thank you.